writing programs that make use of ranges of integers, such as all of the integers between 0 and 10, is such a common task in programming that Python has some built-in functionalities around the ideas of integer ranges. Let's take a look at some simple examples in the conceptual sense. So let's imagine that we want to express a range. What are the properties of a range? What are the things that make up a range of integers? Well, we think about a number line, and we think about, maybe this is -1, 0, 1, and 2. If we want to represent a range, there are some features of a range that we need to specify. Well, we know that we need some bounds of our range. So let's maybe choose all numbers starting from 0. And we're speaking specifically in terms of integers here. So I'm going to use a convention, and let me actually even change the color here. A convention that says if we color in a dot on a number line, we're going to be inclusive of that value. So our range is going to start from 0 inclusive. Okay, meaning 0 is going to be one of the values in this range. And we probably also need to think about, well, where do we end? And for reasons that we'll see with a little bit more detail later, but it has to do with the idea of 0 indexed lists and sequences, and how useful it is to think of the first element to say, in this case, having a starting point of 0, and the stop not being included in our range. We're going to use a different convention for the stopping point, and we're going to have an open circle, right? And our stop in this case would be the value 2, and we're going to call this exclusive, meaning we're going to exclude the value 2 from our range here. So this is a pretty simple range. If we thought about what are the actual values in it, it would just be 0 and 1, right? So pretty simple. And we're only thinking in terms of integers, so we would include 1, but we're not thinking about the values that are fractional between 0 and 1 or 1 and 2, right? Like you would if we were thinking in terms of continuous numbers or floats, right? So our range here is going to be all the numbers between 0, 1, and 2, which is just 0 and 1 because we're excluding 2. Let's imagine this is slightly more interesting, and let me extend my number line a bit here, and say we go up to 5. So 2, 3, 4, and 5. And let's say that our stop was set to 5. Right? What if we wanted to include only the even numbers, such as 0, which we'll consider even, 2, and 4? Well, we need some kind of a step, right? Before we think about how would we get 0, 2, and 4, let's think about the simpler range of 0, 1, 2, 3, 4. So I'm going to use a third descriptor here, which is a step. And in this case, if we use a step of 1 after each value, right? So we step up by 1 after each value, meaning our starting point is 0. So after one step, we would have a value of 1. After another step, we would have a value of 2. Right? But we could imagine, choosing a different step here, such as say a step of 2. In which case, we would have 0, and then we're going to add 2 to 0. So our next item in this range would be 2, and then our next item in this range would be 4. Right? So one of the things that's interesting about a range is based on these 3 values, the start, the stop, and the step, you can ask for any, particular item in the list, like give me the third value in this range, and we can calculate that directly, right? So let's imagine that. Let's imagine in this example, we wanted to figure out, well, what is the third value? Or if we imagine this range, let's call this range a variable name such as a range is going to have these properties: a start of 0, a stop of 5, and a step of 2, right? So what we can do is we can say, okay, well, how would we calculate a range of, say, if we think of these as indices using the subscription notation, a range of index 2, right? So this would also start from 0, so this would be the third item in the range, or index 2. Well, let's imagine this index is, the variable idx, and we're going to use 2 as our idx. How can we compute this? Well, we're going to take our start, which is 0, and we're going to add on to it our index multiplied by our step, right? In this case, which is 2. And in doing so, we would see that, okay, we get, our start. Let me actually color code this. So our start was 0. And if we add on 2, which is our index, multiplied by our step, we have a simple little formula for figuring out, well, okay, you change the index to 1. And now we would know that the value at index 2 could be, or sorry, at index 1 could be calculated by, 1 multiplied by 2 plus 0, which would just be 2. And this works even if we said, okay, well, what if we started from, say, 1? So what if our start was 1 instead of 0, right? Well, we would need to update our calculation a bit, right? So our calculation would be our start, which is 1, and then we add on to that our index, or idx is what we were shorthanding this, our index, which was 1, multiplied by our step, which was 2, right? So 1 plus 2 is 3. And so the item at index 3 in this range would be, or sorry, the item at index 1 in this range would be 3. And that makes sense, right? We're talking about a range starting from 1, going up to 5, but not including 5. Index 0 would be the value 1, and index 1 would be the value 3. So we've got a way of specifying these properties of a range of integers. And the way that it works behind the scenes, Python has some capabilities for figuring, okay, if you ask me for index 0 of this range, the very first item of this range, here's the formula I'll use. And it's the same formula no matter what index. The reason why we keep track of stop is, well, we need to know, when does this range end? And that will allow us to calculate a length using a very similar type of formula and know that there are some bounds here. So let's try working with this in Python with an actual example. I would encourage you to go ahead and set up an example in your code with some of this similar starting point that we have here. So if you want to pause your video, go for it. And what we're going to do is set up some variables. So notice we're going to start from an index of 0, start with a value of 0, stop at 101 not inclusive or exclusive, and have a step of 10. So we expect this to be 0, 10, 20, 30, right? And I set up a variable named arange. Its type is range, which is a built-in type, just like integers, strings, and lists. And range, we'll learn that there are some other ways that we can construct range objects, but the most explicit way, where we specify each of these 3 properties, is we give it as arguments the start, the stop, and the step, which are just the integers that control the characteristics of this range. So if we want to convince ourselves, okay, well, what is a range at index 0? We expect that to be 0, right? Because we're starting from 0. If we print what is a range at index 1, we expect that to be 10, right? Because we start from 0, but we're stepping up by 10. So that would be 10. And you get the point, right? We print a range 2, and so on. Ranges, just like lists and strings, have lengths associated with them. And if we wanted to, we could go calculate that length using these 3 values as well. But for our purposes, we'll just trust that there's a simple calculation for it. And we can say, length of a range is going to tell us how many indices there are starting from 0. So we could print the max value in range, which is just going to be a range. And just like any other list, or we should think of this as a sequence of values, because it's not actually a list, it's more generally a sequence. And we'll talk about that distinction shortly. We can take the length of this range and subtract 1 from it, right, as the index. And that will give us the last index of this range and the value stored at it. So we expect 0, 10, 20, and then because we're going up to, but not including 101, 100 should be the last value in this range, okay? Python lessons.range is what I named my module. And let's see, there we go. So 10, 20, and then the length of a range was 11. And that's kind of confusing, but remember, we're starting from 0. So 0, 10, 20, 30, 40, all the way up to 100. So there's 10 values that are positive and then 0 in addition. So there are 11 values in this range, and the max value is 100. To convince ourselves that this is exclusive, if we said that the stop was 100, then 100 would not be included in this range. And we would see that we get different results when we try and run this. So 10 is the length of the range, and the max value would be 90 because of that exclusivity of the upper bounds. Okay, so let's think just a little bit about how this must be represented in memory and what's going on. I'm just going to print here, a range dot start, and print a range dot stop, and print a range dot step, right? So we can access the characteristics or the properties, the sort of what we think of as like member variables grouped together. These are the characteristics that make up this range, and we can access them through saying a range dot and then start, stop, and step. And we'll print those out, and we'll see that it's going to be 0, 110, as you'd expect. But what's going on in memory in this example? So I'm going to reset my example here and think about this from an environment diagram perspective. Right? Let me erase this example, or that unnecessary G there. Right? So we're going to have a stack with a globals frame. And we set up these 3 variables: start, which was 0, stop, which was 100, and step, which was 10. Okay, and then we construct this range. Now, how ranges are represented or stored in memory behind the scenes, we don't have a good specification of. This is built into the Python language. But for our purposes, the way we'll think about a range is as such. So we're going to have a range object, and it's going to have these 3 properties. Every range will have these 3 properties. We'll have a start, and that's whatever you give as this first parameter when we use all 3 arguments. So start is 0, and stop is 100, and step is 10, right? So there's an object that's a range object that is set up in our heap, right? And a range is going to be bound to this object, just like when we set up a new list, but a range is going to be bound to this object. Now, what I want to point out here and emphasize is notice there's differences between a list, where we keep track of all of the values in it, and a range where we're just keeping track of these 3 properties of what make up a range. But there are some similarities between lists and ranges too, right? Like this idea that we can access specific items from a range. Like the a range at index 0 would be 0, a range at index 1 would be 10. So we've got 2 different things that have some things in common and some things that are less in common. And this is something that we'll see broadly throughout programming. And this is true in the real world too. There are some things that are kind of alike but have different properties. Here we have 2 what we call sequences. Range is a sequence, and we can access any sequence by its indexes or its indices, and we can use the length function to know how many items are in a sequence. List is also a sequence. But there's one other fundamental difference between lists and ranges, which is lists are mutable, meaning we can change the contents of a list. We can reassign new values to different items in the list. We can change its properties. Whereas ranges are immutable, meaning you can't change anything about a range after you've set it up. And this is a distinction that's important because you might want to say, okay, well, let's actually change a at index or a range at index 0 to be like, maybe 10 instead. Well, you'd get an error saying that, hey, you can't actually do this because ranges are immutable. and you can't change them after you've set them up. You can only make more new ranges. So if we wanted to have a range that started from 10, we would just reassign a range to have those different properties. So for example, we could later say, okay, well, what if we wanted to change a range to be a range that starts from 10 to 100 and has a step of say 3. All right. We can reassign a range, meaning what would happen here is if we were to imagine, okay, well, we would print these 3 things would have happened before this. So start would have been 0, stop 100, step 10. And now what we're saying is, okay, we're actually going to reassign a range to be something else. So we're going to set up a new range separate from the original one. We can't change anything about that original range. Its values would be start at 10, stop at 100, not inclusive, and step of 3. Right? One of the really cool things about ranges is that no matter how big your range is, right? This is from 10 to 100, but imagine from 10 to 1 million. We wouldn't have to keep track of all of those values on our heap, right? Each range has only 3 numbers it needs to keep track of. And then when you ask for specific indices within that range, we can compute that number based on the start, the stop, and the step, right? And whether or not it's a valid index. So why are we going through all this trouble? Well, we'll see some very useful places where ranges are going to help us shorten our code. And we learn new and different kinds of loops, such as a for loop. But what we're focused on right now is sort of this idea of sequences and some of the trade-offs between mutability and immutability. Before we talk about those specific trade-offs, I want to mention a few other ways that you can work with ranges that you will commonly see. If you don't specify the step of a range, so for example, if we just specified a range from 10 to 100, the default step is going to be assumed 1. So we're always just going to move forward by 1. So that's one way that we can use it. So I might make a comment here. Default step value is 1. Right? Additionally, there are many, many times that you will want to have ranges that start from 0. In fact, this is so common that if you give only one argument to this range function, which constructs a new range. So for example, if we were to say a range of is a range to 10, here the default we're giving the stop. Stop is 10. Start is 1 by default, and step is 1 by default as well. Right? And so, if we were to then print what is a range 0, it would be 0, a range 1 would be 1, 2, 3, 4, and so on. And why this is useful is when we're trying to move through each of the indices of, say, a list, we can set up a range where the stop is the length of that list. And we'll see reasons for why we might want to do that later. Okay. We've now seen 2 different kinds of objects that are related to one another. And let's make just a few quick notes on the differences between ranges and lists. All right. So list, which we looked at first, versus range. So these things have some attributes in common, right? Or there's some things about these that are common to one another, such as subscription notation. And maybe we'll make a list of the things that are the same or in common and different. Right? So subscription notation is the same. We can use the length function to determine number of items. And this is kind of a weird thing to think about in the context of a range. What do you mean the number of items? Well, if we think about each of the values that's in the range, those are our items, and we access them through the subscription notation. So length just tells us, how many valid items are there, and we could write a loop that moves through each of the items in our range. What's fundamentally different is lists are mutable. And that makes sense, right? We used lists as a way to organize data sequentially, and we can have repeated items in our list. We can have items, out of order or in whatever order we want. Like if we have a to-do list application, you would want the user to be able to specify the exact order, which wouldn't necessarily be alphabetical, and we wouldn't necessarily have any data about the order in the program other than, here's what the user wants it to be. Ranges are not. And you might ask, well, why not? And the key idea here is if we change a range, then we're talking about a completely different range, right? And we think of ranges almost as mathematical ideas like numbers. Right? So the number 5, you can't really change the number 5. 5 has a specific concrete meaning in math. Now you could say, well, if you add 1 to 5, you'll have 6, but that's a different number. It's distinct, right? 5 and 6 are two distinct and different things from one another. And ranges we think of in a very similar way. If you have a range from 0 to 10, that's different from the range that's from 1 to 10. And it's kind of weird to say, well, let's change an existing range when it's so easy to make a new one. With lists, however, there are many cases, like we just saw with sorting, where you might want to actually rearrange the items in it and change things about it that correspond to many real-world scenarios. So mutability is something that's very different between these two things. The other difference is representation. What we mean by representation in computer science is how is this stored in memory? And what this is a very succinct and first introduction to is the idea that we can have two objects which work in very similar ways, right? We can access specific items from each of these things. We can get the length of them, so we can loop through the items. And there are some things that are in common between both lists and ranges. But under the hood, in memory, they're represented in quite different ways. And with a range, you only have to keep track of 3 pieces of data, even if there's thousands or millions of items in that range. And that's through a little sleight of hand. That's just a simple little formula for calculating, okay, if you ask me for the 10th item of this range, here's a little bit of algebra to figure out what that value actually is. What we call things that share properties in common with one another is we think of these as having the same interface, or sharing an interface. So we can interface with a list and a range in the same way. And the interface of these is what we call a sequence in Python. Okay, so the sequence interface is one that if you have something that's a sequence, you can use subscription notation, you can ask for its length. There's some other things too, but these are sort of the 2 most defining features. Can you think of another kind of sequence that you've interacted with? Strings, that's right. So strings are also sequences. They're sequences of characters. You can use subscription notation. You can ask for the length of a string. A string is a sequence of characters. But what's different about strings from lists? Well, lists can be of any type, whereas each item can be of any type, whereas strings, each item's type is a character. Strings are immutable. The only way you can build up a new string is through concatenation or some of the other operators which use concatenation under the hood. And the representation of strings is different too. We're not going to be focused and dig into what that looks like. You'll see that in future classes, but strings have some very specific representations in memory that make them very efficient for our programs to work with. So what we've seen in today's example, in this particular video, is the idea of a range is something we'll use very frequently when we start writing what are called for loops, which we'll learn about later, but they're very valuable there. When we're talking about sequences, we can have many different kinds of sequences that share certain features in common. They share an interface, and this allows us to sort of know what to expect when we work with them. even if behind the scenes their implementation is a little bit different. This is going to be one of the common defining features of when you start writing software. You'll run into many different scenarios where you want some objects to share certain things in common and behave in similar ways so that they're easy to work with and are interchangeable with one another. But you also want their implementations and some of their characteristics to be different. And as we move forward, we'll see some other examples of this. But for now, we've got a list, which is a mutable data type that we can put whatever data we want in it. We can modify its contents. And we've got ranges, which are also sequences, but are immutable and specific to ranges of integer values.